Now, I'm sorry, can you see okay? A little hard to see. We'll do our best. Do we need the light off? It's okay?
It's okay.
For now. Okay. Oh, actually, before I start, are these words anybody knows? I guess we'll see now in a moment. Right, who knows? I'm sure somebody knows what a scalar is. True? Yep. Can you give me an example? Yep. I maybe meant with a unit as well, so like 5 meters. Yeah. So what would be the definition of a scalar, do you think? No. No dictionaries.
Okay.
Danny, what do you know the definition of a scalar?
Scalar quantities are quantities that don't depend on they
Yeah.
they stand on their own. They don't depend on other quantities to form.
Don't know, Danny. Don't know about that. Maybe something else. Anyone else? Ah, come on. I know one of you have heard of this word before and can remember it from high school.
Magnitude and no direction.
That's exactly it.
Describe as a single element.
We have it now. A scalar quantity, thank you, Kehong, it has only magnitude, that means the size, and no direction. For example, walking at 1 step per second is a scalar. However, walking at 1 step per second to my home, why is that not a scalar? Well, because it has a direction to my home. So in the exam, they often ask for a scalar definition with 1 or 2 examples. So before you write this wait, pause. Before you write this definition down, can you think of other examples of scalars to write down? Yeah, what's that, Danny? Temperature is a scalar, correct? What else might be a scalar? Huh? Say again? Time? Yeah, time's a scalar, yeah. Yes, weight's a scalar. Huh? Mass is a scalar. Okay, so in the exam, the definition usually needs 2 examples. Okay, so write down any 2 examples you want with this definition, please. Got it written down? Yeah, got that written down? Yeah, okay. Now, Dami probably can tell me this one. Yeah. A vector is a quantity that has magnitude and direction. Do you remember this word, Ming? Magnitude?
Yeah.
And do you know what the direction is? Direction? So, what's an example? Well, the one we had a moment ago, walking 1 step per second to my home. But can anyone think of other examples of vectors?
Force.
Force is a vector, good.
Speed.
Velocity, not speed, velocity.
Velocity.
Yeah.
Acceleration.
Acceleration, good, yeah. Anything else?
Obstacles.
Yeah, sometimes in some courses, yes, sometimes no. Displacement, yeah, that's one, yeah. The two easiest ones, probably force and velocity. But we'll talk about those later too. Right, do you have that written down? Got that? Yeah? Everyone has that? Yeah. Continue? Yep. Okay. The two most well-known examples of scalars are speeds and velocities, which we were talking about a moment ago. And most native speakers would say they're the same thing, but they're not really. So we need to give the definition of speed, the physics definition of speed, precisely. So does anyone feel like they might know it or remember it from high school or middle school?
Speed don't
Yeah.
have direction.
Correct. It has only magnitude. Correct. And the formula? The definition?
Distance divided by
Yeah. Can we give that as a sentence rather than...
distance per time.
Yeah, that's it. And what word do we like to throw in as well?
Displacement per time.
Oh no. The rate of change of distance travelled per unit time. And Dami, as you said, as a formula, that is speed equals distance travelled over time taken. And of course, what's the units? Meters per second. Right, for the units? Okay. So, please note that definition down. Okay. You got that, folks? Okay, check something here. Yeah. I wonder, for you, do you spell travelled with one L or two? Because it depends on the country, actually. So, UK is two L's, and US is one L. I just wonder, I don't know, would you have spelled it with two naturally, or would you have spelled it with one naturally? You would have spelled it with two? Who would have spelled it with one? Maybe the Canadian? Yes. One?
One.
Really? Okay. I don't know for your home countries which has more influence on your English. Is it UK English or US English? Yes.
Okay.
Come in.
Sorry.
Yeah. Oh, have I got a new student?
Sorry, no. I have to give Min.
Min is right there, yeah.
Min, you have to go to the bank at 10 o'clock. Yeah?
Ah, so she'll need to scoot out early?
You have a new life engine.
Tomorrow.
Is it tomorrow?
Yeah.
It's 3 to go to today at 10 o'clock. And
My email said me it's tomorrow.
Are you sure? Go check it.
Yeah. This is
who's going today then?
Tuesday.
Sorry.
You're for today. You got an email for that? Good stuff. You have all the things you might need?
Who's
Yep.
going today then? Say 2 down.
Fella
You can go today if you want, because there's 3 can go a day.
It's okay. We have Abdul Ali. Abdul Ali down the back has his stuff ready for today.
Have you? Okay, so you're going today and Trisha's going today.
No, this is Abdul Rahman, isn't it?
You
Oh,
already
okay.
have a bank
Is this
account.
you, Abdul Ali?
I'm
not sure.
Okay, go tomorrow then.
No.
Yeah, okay.
So maybe I'll just stick to this. There's 2 on today. So you and Trish are going today. That's fine. Okay, thank you.
Oh, wait there, Sharon. But you said you already have a bank account, so you don't need to open one.
Yeah, I told him.
Oh, okay.
That's fine.
That's fine. Yeah. So he's sorted then. So who is it that is going from this class today?
So
Ming
you're going.
and
You're going
Muhammad
tomorrow.
Ali.
Yeah, we'll
And
go tomorrow.
Scalars.
Does he need a letter or anything?
You have.
Oh, you have all his paperwork.
Yeah.
Okay, good stuff.
Thanks
Good.
a million. Sorry for that.
No problem.
Okay, sorry.
Are you going to? You'll go today?
Tomorrow.
You'll go tomorrow.
Send me
No, that's
tomorrow.
fine. That's fine. Yeah, you can.
Okay.
You'll do it tomorrow then. Fine.
Yeah.
What do you need to bring with you to go to open the account?
Just this, I think.
Just that?
Yeah. Maybe passport. Yeah, passport.
Oh, okay. Yeah. Passport. Yeah, of course. Yeah. You don't have your passport.
Yeah.
Is at home?
Today I didn't bring.
Of course. Yeah. It's safe not to. Okay. Right. When did you open your account? So which bank are you with? Oh, it's AIB as well. Okay. So you're sorted, no problems. Yeah, you're going to head off and take care of the bank stuff now. That's fine. Yeah. If you get finished before the end of the class, you can come back. But like, if there's only like 5 minutes left, it's okay then. You know. Just make sure you watch the videos later for what you missed. Okay. All right. Okay. Did you write that down?
Yeah.
Yeah. Okay. Now, next. Oh yeah, so for example, 50 kilometers per hour. I'll close that in a minute, don't worry. Or 10 meters per second. Or 1 step per second. These are all speeds. Okay? Right. I'll ask you, does anyone think they can tell me what the definition of velocity is? Come on. Right, can anyone tell me what velocity is? It's similar to speed. It is the rate of change of time. Nah.
Sorry, of distance. Sorry, the rate of change.
Displacement.
Yeah? Go on, give me the full sentence, Kehan.
In the given direction.
The change of the displacement in per unit time.
Yeah. So, velocity is the rate of change of position, or more precisely, as Kehan said, displacement, travelled per unit time. Mathematically, velocity is change of displacement over time taken. For example, 50 kilometers north, 50 kilometers per hour north, or 10 meters per second to the finish line, or 1 step per second homebound. Homebound means to my home. They are all velocities. Ooh, windy.
Yeah.
It was hard to cycle this morning. Needed more effort.
Oh,
Did you cycle?
yeah.
Good man. Anyone else cycle? No. Walked?
Yes.
Yeah. Okie dokie? You got that?
Mm-hmm.
Continue?
Yeah.
Yeah? Okay. Right, now, Kei Hong, you mentioned this word a moment ago, displacement.
Yeah.
Do you feel like you can give me a definition of what displacement is?
The change of the position.
Yeah. It's to do with position. It's definitely a vector. Displacement is a vector. It's basically the position. You know? So, for example, here's some displacements. Okay? I could say sun is 1 meter to my left. That's a displacement. Okay? Or I could say Myron is 1.5 meters in front of me. So, displacements is like the point to where something is. Do you understand? Yeah. Okay, you got that, guys? Not yet? Okay. Got that? Now, you have to be careful a little bit. So look at me. If I stand here and I go 1, 2, 3, 4, 5, 6, my distance is 6 steps. But what's my displacement? 0. Because I'm back at where I started. Yeah? Now, if I do this, 1, 2, 3, and then turn and go 4, my distance
It's 4.
is 4. My displacement?
It's 2.
2. Yeah, I'm 2 from where I started. Do you understand the difference?
Yeah.
So just be careful with that. Now, terms like homebound and to the finish line, yeah, they're directions, but they're not very helpful. So we use vectors, we use diagrams that help us with vectors. So we can represent a vector basically as shown, as an arrow. So this here is a picture of a vector. You see, it has a direction, it's pointing, right? And the magnitude is the length. Okay, so for example, like if I put 2 things here, so this vector will be shorter than the vector that points to this. Do you understand? So if this, for example, means 10 meters, then this would mean 5 meters. And this would mean 1 meter. It's a scale. Yeah. So the magnitude is represented by the length of the vector. We call the start of the vector the tail. So I would be the tail. And then this, so if I point here, this is the head. Do you understand? Yeah. And the direction obviously is where it points. Okay. So we'll do some examples with this in a moment, but I would like you to draw this picture, please. Tail, magnitude, direction, and head. Okie dokie. You got that drawn? Yeah? Okay. Got that, son?
Yeah.
Yep. Okay. Right, let's do this example together. Let's draw all of these together. So we'll make a nice big graph. Oh dear. Steady. Right, okay, so the first one is 5 meters per second north. So this is my first vector, A. Okay? The next one is 4 meters per second east. So if that's 5, then 4 would be about here. You see? Okay. So what I'd like you to do, so I want you to try and finish drawing these, and then I'll give you the answers. Okay? Now they get a little bit harder at the end.
Sorry, is everything started from the origin or like from the last?
For this one here, everything is from the origin, because these are all, they're not connected, they're just separate vectors. However, Danny, in a moment we'll see when we start to add vectors together, we'll put the tail and the head together then. Okay. You can draw all of them on one diagram. Okay. A little hard down the end, isn't it? Okie dokie. Shall we have a look? Let's see. The next one, 5 meters per second west. Oh my, sorry, that's terrible. That's C. 1 meter per second south. D. Now, Dammy, please. 3 meters per second, 30 north of east.
Northeast.
North of east means this.
North.
Of east. Of east. North of east.
Oh,
That word there is important.
North.
okay.
North of the east. Above the east.
The east. The
East.
east.
East
The
or
east.
is the right hand side or left?
No, the wrong way. East is the other side.
Oh.
Yeah. Yeah?
Yeah.
Okay, now. North, 3 meters per second, north 30 west. That's F. That's north 30 west. That's what that means. Yeah?
Yeah.
1 meter per second bearing at 30. That's this one.
Like
Here. Where this is 30. That's what bearing means. Bearing means from the north. And then lastly, 2 meters per second at 30.
like
From which direction? If I don't mention a direction like this.
east.
Very good, east. So that would be here. How big? 2. 2 would be about that, whatever. Hey. Okay. So you need to be careful with the English here. Yeah. Be very careful. Okay, continue. You have that?
Yes.
Yeah. Vectors can be added together by using what's called a vector triangle. Consider 2 vectors, A and B. The sum of the vectors, which is called the resultant vector, is OR. You can find out using this picture here. So if you have vector A and vector B and you want to add them together, what you do is you put the
Read.
oh my goodness, tail of B, isn't it, at the head of A. And then the answer is from the tail of A to the head of B. That's called the resultant, which is A plus B. Now, why is it called the resultant? What word is this like in English? Like what, yeah? Like result. Yeah. This is why we call it the resultant. You definitely need to know this word, resultant vector. And I would like you to draw this. This is called the vector triangle. It's how we add 2 vectors together to make a new vector. Now, there are other ways to do it, but this is what we need for now. Okay, have we got that done? Yeah? Okay. Now, you got that, son?
Yes, I remember it.
Oh, good. Okay, continue. A vector can be multiplied by a scalar. So does anybody know what happens when you multiply a vector by a scalar? So if you had a vector and let's say you multiply it by 2, what happens to the vector? What happens to the length of the vector in this case? Doubles, yeah. So, if you multiply a vector by 2, as an example, it will double in length, like you said. What happens if you multiply a vector by a half? Smaller, isn't it? So, like here, if this is vector A, then this is vector 2A. And this is vector a half A. Yep. What happens if you multiply by minus 1?
That was the sign.
Yeah. So this is
Yeah.
minus a.
Mm-hmm.
Yeah. Maybe actually it'd be nice if you draw these examples. That would be good. Right, you got that? Yep, okay. Of course we can add, subtract, multiply and divide scalars, like always. We can multiply or divide a vector by a scalar, like we saw here. We can add or subtract vectors by using the vector triangle. But what we cannot do yet, we cannot multiply two vectors. Now, later we kind of can, but for now we can't multiply them. And for now, and ever, we can never divide a vector by a vector. It's not possible, okay? You cannot do vector A divide vector B. You can never do that. Right. So, here's an example here. I have two vectors. Vector A is 5 kilometers east, and vector B is 5 kilometers per hour north. First, I want you to draw these. Okay, fine. And then, can you add these? Explain, and so on. I'll give you a minute or two, 2 minutes, I think, to try this little question. Let's see what you can come up with. So try this for a minute or two. Okay. You got that? Yeah? No? Maybe? Finish my one? Maybe?
Maybe.
Newest student. Was Gabriel your name? Yeah, okay, good. I wasn't 100% sure. I'm trying to learn everyone's name. Alright. Shall we look at the answer? Yep. Okay, well I hope you got the first part okay. 5 kilometers east could be like this. The heck? Oh yeah, never mind. 5 kilometers east, and then 5 kilometers per hour north. Something like this. Yeah? Okay, fine. That's part A. Can these vectors be added?
No.
You're saying no, Ming? And the reason why? Explain. Because what's different? What's different? Different units. Isn't it?
Yeah.
Consider the vector TB, where t is 2 hours. What is the dimension of TB? What is the dimension of TB? Well, what's the dimension of t? Oh yeah, you have it, Danny, yeah. This is time, and then b, what was b? B was length per time. So as you said, the answer will be, it's of length. Yeah, okay. D. Draw TB. How is TB different to B? Yeah, what's the length of TB? No. 10.
10, no.
10 north. Yeah. So, if that's B, then that's TB. Right? Because the T is 2.
Yeah.
Yeah? Draw the result of A and TB. So, do you remember we used the triangle? What we do, here's A, and then we put TB here, and then this is the resultant. That's E. And finally, F. What does A plus TB represent? You know what? Yeah, but if you were to give it like an explanation with a story, you know, for example, what's A? A is, what was A? 5 kilometers east, wasn't it? So maybe A represents where your friend is, 5 kilometers east, whatever. And what was B? B was 5 kilometers per hour north. So what could B represent? Maybe it represents somebody walking north. You understand what I'm saying?
Yeah.
So, what could A plus TB represent? It's kind of hard. Anyone feel they might have an idea?
Displacement.
Yeah, but give me a little story. What do you think?
Someone walking northeast.
Not too far off, but not quite as straightforward as walking northeasterly. Yeah. So you're right. We think of it as walking, but you need to fix the direction a little bit. So I'll tell you. A represents displacement, and then you add to A this TB. B is like a velocity and T is like a time. So what's happening here is somebody starts at A and then they walk north for 2 hours at a velocity of B. So this represents somebody who starts at A, that's where they're at, they're 5 kilometers to my east, and then this is their velocity that they walk north, and this is for how long that they walk north for. And the or represents where they finish. And this is where they started. Can you see that? So you were close. Yeah? Now it's okay if you didn't 100% get that. I just threw that question in to see.
I think maybe start at 8 time.
We start at A.
8 time.
Start where?
TI.
TI?
TALI. Start at 8.
Oh, start at the tail.
Yeah,
Here.
tail. Yeah.
Ah, no, we actually start here. So, let me take it like this. If T is 0, what would OR equal? It would equal A. So, this is the origin, and that means the person would start at A.
Yeah.
Yeah? Okay, maybe you should write that down. So that I don't think anyone got it. Tricky, I know. Okay, continue. Yeah? Yeah? Okay. Right, next. So, for some of the questions, it'll be useful to know this triangle. Now, we'll learn how to calculate these angles very soon. And you probably already know how to get these angles. But I would still like you to draw this triangle in your notebook. This is a very, very common triangle. It's called the 3-4-5 triangle. You probably have seen it millions of times, right? Millions of times. There are 2 very common triangles, aren't there? There's 3-4-5. And what's the other one? By lengths of sides. You're right, 60-30 is the other common one for the angles. But what are the sides? So you have one that goes 3-4-5. And what are the other common sides? 5, 12, 13.
12, 13,
Yeah.
5.
That's it, yeah. We usually say 5, 12, 13.
Yeah.
Small to big, yeah. Okay, did you draw that? Yeah? And here's our other friend, 5, 12, 13. And here 22.62, 22.62, and 67.38. Got that? Yeah? Continue? Okay. And last one we'll need, it's a common one as well. 1, 1 and root 2. Yeah. Actually, Marwan, you're probably right. I should add that other one as well, the 3060 one. I don't think I have that one. No, I don't actually. Maybe next year. Yeah. Okay, you got that? Yep, right. Let me see it. Okay. This one here now is more like an exam question. Well, kind of, yeah. A man walks 5 steps north, then 5 steps west, then 1 step east, and finally 1 step south. This took 9 seconds. First question, what was his average speed for his journey? Then I want you to draw the 4 velocity vectors. Then I want you to draw the 4 displacement vectors. And then what is the magnitude direction of the final displacement? And then lastly, what was his average velocity? So it starts off easy, and again it gets a little bit hard. I want you to try this first before I give you the answer. Okay, so again I'll give you 2 or 3 minutes. See if you can do this. Now, my tip is draw it very neatly. And actually, I recommend what you do is you make some boxes. You know, like 1, 2, 3, 4, 5. You know, try to make some boxes. It will help you when you draw 5 north, then 5 west, and so on. It'll be a little easier. Okay? Right, I'll give you a minute to try.
So we don't need to draw it XY plane?
Yeah, I recommend just draw like does your notebook have boxes or it's lined? Lined, okay. Yeah, so you might want to draw some boxes in. It'll be helpful. Now you only need, because the biggest one is 5, maybe you could have a 6 by 6 boxes. Okay, how are we doing?
About the velocity vectors?
Yeah.
Because one
Huh?
is the speed constant.
The speed is constant, I suppose, yeah. The velocity is definitely not, because it keeps changing its direction. But we can imagine he's walking at a constant speed. right. Got that? Not yet, okay. You think you can get it, Danny? Feeling confident? Okay. Okay? Shall we look? Let's look. So, like I said, oh, sorry, so ugly. 1, 2, 3, 4, 5. 1, 2, huh? I have boxes, but they're too small. 1, 2. No, 1, 2. Yeah, I could, couldn't I? 1, 2, 3. I'll do it like how you did it. Okay, let's begin. So, a man walks 5 steps north. So he starts here, and then he walks 1, 2, 3, 4, 5 to here. Yeah? Then 5 steps west. 1, 2, 3, 4, 5. Then 1 step east, and 1 step south. Okay, anyways, we'll draw this in a moment. The first question is, what is his average speed? So we know that the average speed will be total distance over total time. So 5, 10, 11, 12 steps. And it took him 9 seconds, we're told, isn't it? So what's that? 1.333 steps, or what? Steps. All right, S. No, I can't use S. ST. Steps per second. So that is 1.33 steps per second. Okay, fine, yeah? B. Draw the 4 velocity vectors. Yeah? So I'm not sure how long to draw the vector just yet, so well, he's going okay, I'm just going to draw it in roughly. So he first heads north. No, yeah, maybe, whatever. Yeah, I don't know how long they are, but what's important is they're all the same length. Yeah, and then he heads right, and then he heads down, like that. They're the 4 velocities. Okay. Now, if you want to draw the full length, yeah, okay, not really. I used to do that, and then I realized I'm kind of doing it wrong if I do that. The next one is the 4 displacement vectors. That's a little easier to draw. So the 4 displacement vectors, the first one is that. Okay? The second one, you have 2 choices. Do you? No, you don't. You have only 1 choice. You have to draw it like this. That's the second one. Then that's the third one. And then that's the fourth one. So displacement is always from the origin, from the start. Okay? So it's like you point to where he is. That's the displacement. Yeah? Okay. And then D. What is the magnitude and direction of his final displacement vector? So the final one is this one here, isn't it?
Yeah.
Can you see that?
Yeah.
Right, well look at this. This is nice. How many units is this? 1, 2, 3, 4. And here? 1, 2, 3, 4. So what's this angle? 45. Yeah? And if this is 4 and this is 4, how big is this? 4 root 2. Isn't it? And this is 45 degrees. So the answer is the magnitude is 4 root 2 steps, and the direction, that is north-west. Yeah? And finally, E. What was his average velocity? Now, let's calculate this. Velocity? Do you remember what velocity is, the formula? Displacement?
And direction.
With direction, yeah. Displacement and direction over time. Now, what is his displacement at the end, the final displacement? It's 4 root 2 at northwest. Yes?
Yes.
And what's his time? 9 seconds. Yes?
Yeah.
Can somebody type in 4 root 2 divided by 9? What's that? 4 root 2 divided by 9. Six.
2, 8,
8, 5, so it would be 629?
yeah.
Yeah. Steps per second northwest. Now, guys, you must not forget the direction. Why? Because velocity is what's velocity? It's a vector. So if it's a vector, it must have a direction. And in this case, the direction is northwest. Now, I want you to notice something. This is important. Notice, what was the average speed? The average speed was 1.33 steps per second. What was the average velocity? Not 1.33. Can you see how different they are? This is the average speed, and this is the average velocity. Not the same thing. Now, I saw this question in the exam before. It was a question, it was a boat. You know, a boat heads north and a boat heads west. What is the average speed? And then the second question was, what was the average velocity? So they actually asked you for the average speed and the speed and velocity. So I have seen this on the exam. So this is definitely an exam type of question. Now, I don't know how many of you got this answer at the end. It was a little hard. Did anyone get 629? No? No one? Well, I hope all of you got 1.33. Yeah, okay. And did you get 4, 4 and 4 root 2? No. Okay. It's a good thing we practiced, so. Right, did you write? So I think some of you need to write something down. Yep. Well, I'm glad you're all learning something new. That, you know, it's not all stuff you can easily do. Right? Continue?
Yeah.
Yeah. Okay. Right, consider vectors A and B. We say vector addition is commutative. That is, A plus B is the same vector as B plus A. I think you should make note of that. I mean, maybe you knew that already, but maybe you didn't know this word.
Yeah.
Yeah. Is let's see. Well, I can give you a little simple proof. Like, say here is vector A, and then here is vector B. If I draw this, this is A plus B. Here it is here. A plus B. Okay? But if I draw it the other way, there's B, and there's A, and here is vector A plus B. Can you see that the vector A plus B is the same vector? It doesn't matter if it's A plus B or B plus A. You get the same answer. Okay? By the way, actually, I forgot to mention this earlier, but how would you do A minus B? Yeah, what you do, you change this to A plus minus B. So, for example, in this picture, what you would do is you would keep the A, there's A, and then if that's B, then this one here, that's minus B. So then A plus minus B is a vector that way. Yeah? So that's how you minus vectors, how you subtract them. Yeah? Okay. I think I would like you to draw that in your notebook with the word commutative. Let's have a look here at the question. Yeah. Nice. Okay. Right, did you draw that?
Yeah.
Yeah? Now, there's about 18 minutes left. And I can look at the homework and I can see there are 3 questions to do. But they're kind of easy questions. You should definitely get them finished now and then have no homework, which will be nice. Okay. How long did it take you to do those other 3 questions when you tried them? 20 minutes? Yeah. Yeah, okay. So you should get these done now, okay? So, Gabriel, you might have to sit, you don't have Moodle yet, I don't think. You don't have you only registered this morning, didn't you? Yeah, so you need to get login access. So maybe you could share with Kei Hong. Do you have the questions on your phone to show him? You have Moodle on your phone.
Yeah.
Gabriel doesn't have Moodle yet. Maybe you can show him the questions. Yeah? Right. If you can get a start on those questions now, please, for 15 minutes. 15 minutes. Can I close this?
Yeah.
Gabriel, these lessons get recorded. So you only missed one lesson, which was on Friday, where we were talking about units, meters, kilometers, and all that. So once you have your login access, you can watch that lesson later then. So